Haven't you guys grown to trust me by now that I do have a plan for your good? Really, even though 12 is harder, it's easier. And you'll see what I mean. At least with the method I'm going to give. This is the easier way. All right. So we are graphing. This will be a super easy section, actually. This will probably, let me predict, this will probably be your favorite homework, this section of the whole semester. You'll get it done in about 10 minutes. It'll be that. Once I show you the method, just go boom, 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 boom. 7.5. Now, the next one will be, 7.6 will be more work. But 7.5, this will be total cake section. I'm going to show you some tricks. So, okay, 7.5. What we're doing here, first off, is we're graphing. Now, you guys know, if they give you an equation like 2x plus 3y is 12 or whatever, and you graph that, what does the picture end up looking like? Is it a happy face graph? I mean, I'm sorry, I'm just being goofy. It's not. What kind of a graph is it, though? I do mean that. I am serious about that. What does the picture look like? Straight line. Good. Everybody with me on that? The picture will be a straight line. Why? How do you know from the equation that the picture will be a straight line? What makes that happen? You know.
Say it's a normal x?
Yes. Good job. Good memory. It's x to the first power, normal x, y to the first power, normal y. Exactly. It's all about the x and the y just being regular, first power, right? Now, what if you suddenly throw a 2 power on the x instead of a regular x? It does something strange. Specifically, it brings in curvature. That's what brings the bending. Is everybody aware of that? That's the part I want to make really clear. When you get higher powers on the x or the y, that's what brings the curvature into graphs instead of being straight lines. Now they have some bending going on. In particular, when x is squared and y is not, like that right there, it is a U-shaped graph. Well, you may know the official name of a U-shaped graph? It's called a parabola. So, yeah, if you have x squared, you get a parabola. It can be going up or it can be going down. Have a parabola going up or down when you have x squared and y to the first power. That's what these two sections, 7.5 and 7.6, the last two sections that are on next week's exam, are all about. How do we graph these U-shapes? How do we graph these parabolas, these things that have, notice, x squared, and where's y? I don't see y up there. Where's y? Good. So everybody remember that the function letter, f of x, this is y. So that's y, which is what? Just first power, just normal y, right? And the x is squared. So when you have x squared and y to the first power, you get a parabola, a U-shape, either going up or down. It's not a straight line anymore. It has curvature because of the higher power. It's a parabola. Okay. So, well, how do you graph a parabola? When we graph a straight line, how many points do you need to graph a straight line?
2.
Yeah, just 2. That's all you really... More is okay, but you don't have to have more, do you? If you have just 2 points, like if I say, hey, guys, I'm thinking of a straight line, and it goes through this point, and it goes through that point. The mystery's over. You know, you can make that line. It takes forever to erase this stuff now. There we go. All right. You know, there it is. Boom. I mean, there's no other straight line that goes through those 2 points. But if I said, hey, guys, I'm thinking of a U-shape, and it goes through this point and this point. Do you got it now? No way. We need a lot more than 2 points, right? Well, I hope you don't think that's enough. You might be thinking, wait a minute, we got it. It's that. Maybe. But maybe it's this. That's a U-shape going through those same 2 points, right? Maybe it's, maybe it's way over here and it hits here and hits, who knows? Just because you have 2 dots, that's not nearly enough information to know how to graph an entire U-shape, right? So we need a lot more information, sort of. But really, if you think about it, you need what if you know you're graphing a U-shape, which we are in these 2 sections, you need one really important point. What's the most important point in a U-shape? The vertex, the center, the middle, huh? If somebody tells you, hey, okay, you're graphing a U-shape and here's the middle, that is a huge, huge help. If somebody just says, okay, it's a U-shape, the middle goes through right there, that dot, over 3 up 2 or whatever. The middle of the U-shape is right through that dot. You've almost got it. All you need now is one other point. If I said, okay, Ed, here's another point. Well, that's it then. I got it. Those 2 points would be enough, wouldn't they? So if you have the center and then one other point, that's great. You can't just have any 2 points like you do for a line. You guys tracking with me? Am I making sense? If you have the center and one other point, that'll do it for making a U shape. Okay, so it's all about getting our hands on the center. How do we get the center of a U shape? Well, I got a little trick. Get this all erased. All I'm doing is erasing. Okay, let me write this thing out. Y equals 1/3 x plus 2 squared plus 9. There's my equation, right? Mm-hmm. The center of the U shape. Oh, I need to move it up here because I need more room. So put it up here. So the center of the U shape is the opposite of the number next to x and the same as the other number on the far right side. So in other words, it's the opposite of this. It's the same as that. In other words, what's the opposite of 2? Negative 2. What's the same as 9? Well, 9. That's the center. That's the middle of the U shape. All you got to do is go opposite same. Let's go to the graph now. Whoops, have a little more room here. Let's go to the graph. So back to, right, this is x, this is y. Back to up 9. 4, 5, 6, 7, 8, 9. Boom, there it is. Back to up 9. That dot is the most, we've already got 90% of the battle's over already. We've got the most important point on the U shape. We got the middle. We got the center, formerly called the vertex. We've got it. See what I did there? Is everybody okay with that? Just opposite, same. Now, are we good? Let me know if I'm confusing. So it's whatever number's in the parenthesis next to x, the opposite of that is your x, and the same as the other number is your y. Opposite, same. Now that we have the center, we just need one other dot. Remember we talked about if you have the center and then one, because what we don't know now is this a U shape? Is it going up? You know, is it going up from here, or is it like going down from here? And also, is it going up like real narrow, or is it going up real wide, or down real narrow, or down real wide? You know, we know the middle, but what does it do, up or down, and narrow or wide from that middle? Well, how you figure that out? It's all about this fraction in the front of the parentheses, and that fraction is like a slope. It's not really a slope. That's why I say like a slope. This is my cheaty little method. I'm kind of cheating, so to speak. I really am. Nobody else teaches it this way. They're a little more integrous than me. I'm kind of a slippery math teacher, I guess. So this isn't really a math rule that always works. That's why I say it's like a slope. It'll always work for this section. It'll always work for these U shapes. So I'm letting you know up front. This is not always the case. It's not really a slope, but it'll work. It's real nice the way it works. This is your rise, and this is your run. Remember slope? Slope is, I wrote rum. Rise and run. It is, slopes are rise over run, aren't they? So in other words, from this center, if you go what? Up 1, rise, over 3, 1, 2, 3, put a dot, that'll be a point on the graph. In other words, the graph will go like that. Tells you exactly how wide the branch is. Does that make sense what I did? I went up 1, over 3. Rise over run, like you would a slope, huh? But why I say it's like a slope, not really a slope, is because I didn't connect those with a straight line. But slopes are for straight lines. This isn't a straight line. It's sloped. It's sloped. It's curved, right? It's curved. It's not really a slope, but it'll always work this way for these U shapes. Up 1 over 3. Now, what about the other side of the U shape? It's the same, right? Because it's totally, the U shapes are same on both sides, huh? So if it was up 1, right 3, how do you think I find the other dot?
Down 1.
Up 1, left 3. Same thing, right? So just go 3 the other way. There's the other dot, and we're done. There's our U shape. We know exactly how wide it is, exactly what the center is. That's it. You see, if this fraction in the front is positive, then the U shape's going up because your rise is positive. If that fraction in the front was a negative 1/3, which they'll give us in a minute, then the U-shape's going down because you would go down 1, right 3, and left 3. We always do the run both ways, don't we? Right 3 and left 3 because, you know, a U-shape opens right and left, up or down, right and left. Is that good on that? Now, there's some other silly little questions which I'll show you how to answer, but that's the main thing, is that picture. So let me go over that one more time. You just look at what's next to x. Don't erase it. You look at what's next to x in the parentheses, and you do opposite. Opposite of positive 2 is negative 2. The same as the number off to the right, 9. That's your center. Back 2, up 9. You put that dot on your graph. That's the most important point, called the vertex, the center. And then from there, you do the slope in the front, like a slope. Go up 1, right 3, and then left 3. And you put a dot on each side, and that's your shape. Now, the questions they're going to ask us, the first question is they're going to say, what's the vertex? And that vertex is a fancy word for center. So they're saying, what's the center? The center is the -2, 9, the center. The next question they're going to ask us is, what's the line of symmetry? Symmetry means same. So when it means this line right here. That line that spears right through the middle of the U shape, it's called the symmetry lines, right? The shape is the same, it's symmetrical on both sides of that line. So what's the equation? They actually want the equation of that line. Where does that line hit? Look down here.
X equals -2.
Yeah, it's hitting -2 because remember it went through the x value of goes through the center. So it goes through the x value -2, doesn't it? Mm-hmm. So the equation is x equals -2, right? It hits the x-axis at -2. Does that make sense? And then they're going to ask you, they're going to say, hey, does this graph have like a top or a bottom? Does this graph have a highest point or a lowest point? What am I talking about? Does this graph, I'm talking about the purple graph there, the U shape, the purple U shape. Does it have a top, a highest point? No, it goes up forever. It's got no top. It goes up, 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 and away, doesn't it? So it does not have a top. It does not have a max. No max. No maximum value. No highest value, right? But it does have a bottom. It does have a lowest value. What's its lowest value? How low does it go?
9.
Yeah, right here at 9. 9 is the minimum value. It's as low as it goes. It has a bottom but no top. Now, for the U-shapes that go the other way, which we'll do in a minute, the U-shapes going down, they have no bottom, no minimum, but they have a top. They have a max. Do you see the difference? It just depends which way that U-shape's going. If the arrows are going up, then it has no top. It goes up forever, so it has a bottom. If the arrows are going down, it has no bottom. It has a max, it has a top. So, okay, and what is that minimum value? Well, it's 9. Notice both those numbers, the last two answers, so it's going to have a minimum at 9. A min, the lowest value, lowest height at 9. Notice the last two answers we just got, -2 and 9, where'd they come from? The center. The center's the whole story, right? You see how the center is almost everything for these U-shapes. So basically, every one of these questions, this is why this will be like a 10-minute homework assignment for you. You'll just look at the parentheses, you'll go opposite same, you'll write that down, you look in the front slope, up 1 over 3, and then you'll go, okay, line of symmetry, whatever the x value is, every time. Next question, whatever the y value is, every time. Just like that, because that's everything. The center's everything.
Okay, you managed to make me.
And then they'll show pictures and they'll say which one's right, and that'll be you'll know it right away because we've already got the picture. And that's it. That's all the questions for that one. Does that make sense? All right, let's try another one. All right, let's start here. Let's do number 11. So try that one. So start by finding the center of the U shape. And that's opposite same, right? Opposite same. So what's the center?
Negative 4, 2.
Negative 4, 2. The vertex is negative 4, 2. So put that on your graph. Everybody good there? Opposite, same. And now we need the thing that's like a slope, what's in front. And you got to make that a fraction, huh? That negative 2 that's in the front there. How do you make that like two numbers, so fraction? Put it over 1, huh? We've done that before. It's negative 2 over 1, isn't it? That way you can treat it as a rise over run.
Down to over 1.
So rise and run. Is that good? It's negative, huh? So this U-shape's going down, isn't it?
Mm-hmm.
It's down 2. So we're going to go down 2 over 1. And, of course, you go 1 the other way also. So down 2 over 1 and back 1. There it is. There's the two dots. There's the U-shape. We good there? Seem pretty easy? Quick and easy way to graph a U-shape? Now, can you answer the various questions? We've already got the vertex. That's the center. Then they're going to ask, what is it? Line of symmetry.
Negative x equals negative 4.
And then, does it have a max or a min? And what is that?
Maximum is x is 2.
So this one, so what's the line of symmetry? If I say the line of symmetry is negative 4, I'm making a small mistake, which I don't want to hold you up in your homework, so let me do it wrong. What's wrong with that? Well, what they'll say in the blue line is they'll say, give us an equation. They actually want like an x or y in there, in other words. So you can't just say the number. For the line, remember, this is a line. So lines have equations. So it's not just a point. They want to know the equation of that line. So what's the equation of that green line spearing right through the middle of that line of symmetry? It's x equals, it hits the x-axis at negative 4, doesn't it? So don't just say negative 4, it'll mark you wrong. It's x equals negative 4. They want the equation, they want the x. That good? And does this U-shape have a maximum or a minimum?
Maximum. No
Yeah.
minimum.
He's got a max, which is 2. A max at 2.
No.
We're done. What's that?
No.
No minimum, right? Because it goes down forever, doesn't it? So it has no bottom, no lowest point. It's like a bottomless pit. There we go. Is that easy? Is that okay? All is well?
So we shouldn't be afraid of parabolas at all.
Not yet. They'll get trickier. Later into the course, we'll start turning them sideways. We'll do some fancier stuff with them. To number 10. Yeah, there it is. Okay. So y equals x plus 1 squared minus 4. Try that one. Same kind of thing. Opposite same.
So our rise over 1 is going to be 1, correct?
So what is that slope in front of those parentheses? There's nothing in front of the parentheses. So what's my slope? 1 over 1. Right, I knew you guys would know it. 1 over 1. Yeah, you just do 1 over 1. Exactly. Exactly. Rest is the same. So answer the various questions. Line of symmetry. And max or min. All right, so what's the center? Opposite, same. So it's minus 1, minus 4. We good there? So back 1, down 4. There it is. There's the center of the U shape. And then where's it going from there? Rise or run, it's a 1 over 1. So it goes up 1 over 1, huh? And it also has to go the other way because it's symmetrical. Is that good? And what's the line of symmetry? It's that line that spears right through the middle of the shape. It's this line, huh? Yeah, and the x, don't forget the x, huh? Hits the x-axis at -1. Right? Mine looks kind of bent. Does this thing have a maximum or a minimum? Yeah, it has a lowest. This is the bottom of it, right? Has a minimum, which is -4. A minimum of -4. So again, it's always the x-coordinate and the y-coordinate of the center that are the two answers to the other questions. So it's like the center's everything, and we've got the center super easy by just doing opposite same. That good? Questions? Easiest homework you've had all semester? All right. Fool you in, fool you.
Yeah, you know, what if that's exactly what they want us to think, you know? You said so yourself, math isn't meant to be easy.
All right, try that one. So now they're going to start dropping things out of the problem. But you know what to do about that. Do a little plastic surgery. Remove the wrinkles. Give it the look you need without changing any true values. So first thing is we need to find the center. Center is always opposite of whatever's in the parentheses next to x, and then the same as whatever number is further off to the right, but there is no number further off to the right. So what number could I write in there and not change? Could I go +7? No, that would be different. Adding 7 is different than adding nothing. So, yeah, it's add 0, isn't it? That's the same, and you knew that. So that's all you do, right? So the rest is, so opposite same. So what's the center? +4, 0. +4, 0. So there's the center. Oh, yeah, no, this one has a little trick. Yeah, let me, I'm kind of making up. I'm not making up. I am. I'm sort of making up this little trick method I'm giving you for graphing. It's kind of not legitimate. and here you start to see that -1/2 thing. I assume, I would too, that what you're thinking is it's down 1 over 2, huh? Right? And that's what it would be if it was a real slope. But remember I said it's like a slope. It's kind of like eating stuff that's like butter. It's not really butter, right? It's not really sugar. It's like sugar. That's like a slope. It's not really a slope. Well, here we start to see some of the artificial effects. It's not really a slope, right? It's curved, first off. It's not a straight line. So anyway, you got to put it over 1. It really means the whole thing over 1. You might think, no, it's already over 2. Yeah, you can't. It's not a real slope. That's what I'm saying. So in other words, what you do is instead of going down 1 over 2, this whole thing is your down, and you go over 1. So now as you go, if this is -1, you only go down 1/2 a unit, and then over 1. And you might think, well, isn't that the same? It's not. It's not the same. It'd be off a little bit if you did it the other way. So that's the truth. That's where it really resides. It's like that. So it's down. So whatever number. So let me, to make this simple, that's what I'm trying to do here. Whatever number's in the front, that literally, exactly is your up or down, and it's always over 1. That'll work. That'll always work. So whatever number you have in the front, be it a fraction, be it a whole number, be it whatever it be, whatever it is, that's the amount up or down from the center. And then always right one, left one. Does that make sense?
So how do you know when to put it over a 1 and when not? Right.
Oh, did I do the first one wrong? All of a sudden because you always put it over 1 is the answer. But I think I didn't. Did I? Oh, that was wrong. Sorry. But anyway, it worked out. I mean, it's the multiple choice option, they don't narrow it down that much. So you'd get it right. You know what I mean? Like if you look back, there's no chance for mistake because they only give you 4 options on the multiple choice. It's obvious which one's the right one. But technically this was wrong. I should have actually gone up a third. Right one. It's always over 1. I'm sorry. I told you a lie. I was thinking it was more of a fraction than more of a slope than it really is. That should have been up a third. Right. So always go right 1, left 1. Always with this. It's never really a slope. Always that number. So I should have got up a third. Right 1, left 1. But it's going to look basically the same. Not exactly the same.
So all fractions are over 1?
Yes. Everything is over 1. All fractions, all whole numbers, because this thing's not really a slope. We're kind of bending the rules here.
So let's redo everything.
So it's not going to look hardly any different when you do it. It's going to be virtually the same. But I want to tell you the truth. That is my job. Yeah, so you're supposed to always put it over 1. Always over 1. Never, it's always over 1. So, anyway, it won't make a big difference in the look. It'll look virtually the same. So there it is, and then you know all the answers to the questions, right? Max, min, symmetry, all that. Same as usual. Is that good? Does that make sense? It's not really a slope. It's a fake deal. Now, I'm saving you tons of work. I'll show you what they have you do if you don't do this little trick. Anyway, I'll show you in a minute. So let's try another one. I want to do the later ones first is because in some ways it's trickier when they leave more out, when there's less to look at. Okay, so try that one. So they're missing a little bit of stuff here. So I think you know what to do on this. And so what fraction's really in front? 1 over 1. And what number's really at the back? Plus 0, yeah. The rest is the same, huh? So just leave it so far. So take it from there. I'm sure you can finish it quite easily. Okay, so opposite, same. So what's the center? Negative 1, 0. We good? Back 1, up 0. Like that. All right, and then we go, this is rise over run. And so we go up 1, over 1, and you go over 1 the other way. And oops, I missed. There it is. There's the U shape.
Oh, never mind.
All good? So we went up 1, over 1, and then we also go the other way. And so then the, the line of symmetry would be, it's the line that spears right through the middle of the shape. Yeah, careful, don't forget the x. They want the x equals negative 1. And does this one have a max or min? It has a bottom, has a minimum. What's the minimum value? 0. Right, the y. It's always the x value and the y value. They're those two answers. Centers everything. Good? All right. We're using, we like to have stuff there. That's why I did it backwards. So see how you do on this one. So we got y equals negative 4x squared. So you got to fill in everything that's missing, you know, do a little plastic surgery, give it the look we need so we can do our graphing thing. So what's missing? You need to go x plus 0 squared plus 0. Does that make sense? Or minus 0, whatever, it doesn't matter. Right? See, that's the same thing, isn't it? X plus nothing is x, isn't it? And add nothing, right? This nothing and this nothing are nothing. So it's the same as if they're not there. But it's important that I see those two so I know how to do the opposite same trick. What's the opposite of 0? 0, and the same as 0 is 0. It's 0, 0. So in other words, the center of this one is the origin, isn't it? This one is centered at the origin. That's all that means. When there's no numbers in the parenthesis next to x, and there's no other number off to the right, they're both zeros, aren't they? That's what that means. They're both 0. Is that good? So 0, 0 is the center on that one. Opposite same, 0, 0. So, all right, and then what do you do with the slope? What's the slope trick on this one? Negative 4 over 1, right? Just put that over 1. We always put it over 1. Even if it's a fraction, because it's like a slope, but not really a slope. So go down 4. So from the center, which is at the origin, go down 4 over 1. Down 4 over 1. Down 4 over 1. And then you go the other way 1. Because these things are always symmetric, aren't they? So this one's going down. Negative in the front means the U-shape's going down, huh?
So the max is 0 and the minimum.
We good? This making sense? We happy? I'm looking for happy looks. I think this should make you happy. It's the easiest section all semester, right? No? All right. So, and what's the line of symmetry? Right through the middle there. That's x is 0, isn't it? It's the x-coordinate. And what's this one have a min or max? This one has a top, has a, not a mix, but a max. Has a max of 0. The highest it ever goes to 0. And it goes much lower than that, but it never goes above 0. So it's a max. Easy? So that's why I didn't start with the early ones, because they're missing stuff. You just fill them in. Right? So I just filled in these zeros so I could do my graphing thing. Okay, so try that one. So y equals negative 1/3 x squared. So fill in the zeros that are missing. And what are you going to do with that negative 1/3 in the front? Does that mean down 1 over 3? If it was a real slope, it would, but it's like a slope. So just put it over 1, right? Put that whole 1/3 over 1. You're going to go down 1/3 over 1. We always go over 1. Because it's not really a slope.
But it's kind of like
on the, when you split it up, you do x minus 0 or x plus 0. It doesn't really matter, right?
Right.
Okay.
It doesn't matter if you put minus 0, plus 0, or whatever. It's just 0. Negative 0 is still just 0, right? So then we do opposite same, and it's just 0, 0. So it's the origin. So this one, again, is centered at the origin, isn't it? 0, 0. We good there? Centered at 0, 0. Is this U shape going up or going down? It's parabola. Yeah, negative in the front. Put that whole thing over 1, right? Because that's the weird part of not really being a slope. It's like a slope. So it's down a third over 1. So if this is negative 1, it's only down a third of the way over 1. And then back 1. There it is. Is that good? Down a third. Only down a little bit. Right and left 1. You always go right and left 1. Because it's not really a slope. It's like a slope.
Plus or minus. So
So the line of symmetry is this line, which is x is 0. Oh. And this is going to have a min or a max. The maximum, which is 0, like the last one. Good? All is well? Is all well?
I'm not scared.
Little trick works. First off, hey, let's look at what they say. So let's go back to this when we started with number 12. What is our method? What's the center of that one? How do we do the center of y equals 1/3 x plus 2 squared plus 9? What's the center?
Opposite same.
Opposite same. We just go opposite same, which is -2, 9. That's the center, right? And then from there, we just do it real easy. We just go, okay, it's back 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Back 2, up 9. And is the U shape going up or down from that center? Yeah, it's going up. And you take the 1/3 and you put it over 1, so it's going up a third, right 1, left 1. So as you know, there it is, and da-da-da-da-da. Well, look at what they say. Well, actually, before I look at what they say, why is this true? Like, why, if I was you, I would wonder, why opposite same, Mr. Heron? Why -2, 9? Why opposite same? Why is that point going to be the center point? Well, look, if you take this equation, 1/3, x plus 2 squared plus 9, y equals, right? And you put in the opposite of the x value. You put in negative, you plug in x as -2. What's going to happen to that equation? If you plug a -2 in here for x, what is y going to equal? 1/3 times what? -2 plus 2? 0, right? Putting in the opposite makes it 0. Okay, and what's 1/3 times 0 squared? What's 0 squared? 0 times 0? 0 times 1/3? 0. Plus 9? What does y equal? So when you put in x opposite, you get y same as whatever number was off to the right. It's not some deep, dark mystery. Of course. You put in x opposite, it drops this whole piece out. Because it makes it 0, doesn't it? And so y just equals the same as, not opposite, but same as, whatever number was on the right, huh? That's pretty simple, right? It's not some deep, dark mystery, as I said. Put in x opposite, and y will be the same, and that will be the middle. Of course that's got to work, doesn't it? Now, what about my little slope trick? And that is mine. I'm going to own that one. I read it in no math book, saw it nowhere. It's my own original. It's a Mr. Heron original. It's my only original. I'm sure a million other math teachers have seen it and describe it all the time. I just haven't happened to ever notice one. And one of my colleagues saw me doing it the other day and kind of scolded me and said, that's not formal math. What are you really doing there? I'm like, I know. I'm just showing them tricks. Anyway, so that's the real truth of it. But you see how the trick works? It's not that complex. If you basically go right 1, if you go right 1 of what's in the center, where would I be? I would be at -1. This is -2. So you go right 1, you're at -1, right? If you plug in -1 to the original equation, if you go right of the center by 1, what is this going to equal?
Left of the center by 1.
1 squared, right? -1 plus 2, that's 1 squared. So what? Well, 1 squared is 1. So this is going to be 1/3 plus 9. In other words, it's going to be the height that started at 9 plus 1/3. Rise 1/3, you see? It's not deep, dark mystery. Of course, you're putting in whatever will make this piece 1. That's all I observed. I thought, hey, if we just go right 1, it'll be 1. And this is 1. And 1 times this plus this, that's just the rise. We could just do that. Now, why I wanted to do that, it's hard, isn't it? It feels like, tell me if you think this is made up or whatever, it feels like they write math books only for math teachers. They didn't really write it for students. You like got to already know the subject first to read the book. It feels like it. That's what they should do. But it doesn't feel like they are, right? It feels like they're trying to write it for people that already know the subject. It doesn't feel like they're trying to help sometimes, right? It's like, are you guys trying to help, or are you just trying to sound important? So, right here they're saying it, but they're saying it in math talk. Oh, they're saying what? They're saying the opposite same trick, I told you. You know, opposite same. How are they saying it? Does anybody see? Look at that. See that? See what's next to x? Now, what have I told you guys? Whatever's next to x, you just do the opposite. And then the same as whatever's out here, right? So, what would be the opposite? They're calling it negative h. See that right there? Negative h next to x. So what's the opposite of negative h? Positive h, or regular h. Well, see down here they say x is regular h. Rather than just saying opposite, they call it minus h here, and down here they say regular h. That's their way of saying opposite in math talk. Right? And then, see what they said about k later? They said regular k, which is exactly what this is. There it is. So they're saying that. Okay, but anyway, that isn't mainly what I want to show.